But you know, it's again, it's a higher level thing. So you have to go level by level to understand these things. So here's a diagram how it all works, but it's all physics. You have diffusion in there. You have free energy input. I mean, you might not know what these things mean, but they're all basically physics. The structure of the protein. You have this asymmetry in there, and all of those things together, they explain how these things work, right? So even entropy, here's Maya again. Biological systems are open systems. The principles of entropy, therefore, are not applicable. What? That's crazy. I mean, even the assembly of structures in cells are driven by entropy production. So, for example, these cytoskeleton things called microtubules, when they assemble themselves, they're actually driven by an increase in the entropy of the surrounding water. So, lots of misunderstanding out there. So, what I'm getting to, I'm kind of wrapping things up a little bit so we can have a discussion here, is that you need both, right? You need a holistic and a reductionist view of things. And this is kind of like the reductionist idea. Here are kind of the holist ideas, if you want to call them that really are not part of physics, that you need both strands to understand biology, if you want. And physics works down here, and it kind of works less and less as you go up the ladder, if you want. You know, it has less and less to do with these things up here. But you know, it's important to understand the structure and function of molecules in your cells. It's important to understand how energy is transformed and transmitted in your body, the influence of things like entropy, what kind of universal laws apply to biology. That's all physics and chemistry. On the other hand, you have things like historical accidents, you have variations, you have there's still purpose there, right? I mean, a molecule has a purpose, right? I mean, a certain enzyme or a DNA has a certain purpose, but that purpose cannot be deduced from physics, right? If you wouldn't know anything about biology and I give you a DNA, you'd say, oh, that's kind of a cool molecule, but you wouldn't figure out that this particular stretch of DNA tells some kind of fly to have blue eyes or something, you know, whatever. I don't think flies have blue eyes since they have compound eyes, but you know, this was just a joke. But you know, you wouldn't know that. That's not physics, right? You cannot explain it in physics. So, and just even to explain molecular biology, you need both of those things, right? Because you want to know what a molecule does, at the same time you want to know how it works. And then you go up to cells, and you go up to tissues, organs, and then once you come to like, you know, looking at whole animals and how they interact, physics has basically nothing to do with that. Not directly, I mean, but going back step by step, everything builds on everything else, right? An animal has certain behavior because it eats certain foods. That has to do with how its organs work. Its organs work in a certain way because the cells work in a certain way. They have a certain biochemistry that goes back to the molecular biology of things, which depends on the structure, function, energy, and entropy, and all those other things. And of course also on historical accidents and evolution, which is not physics. But all of these things build on each other. Why would you want to draw a line between somewhere here and say like, oh, you know, this far, not further, or this has nothing to do with that, or I don't know. But you read those things. I read those things. They say like, oh, you know, science is really not a connected whole. It's like this biology over here, and physics over there, and chemistry over there, and astronomy over here, and they have nothing to do with each other. It's just not true. Here's an example, as far as I understand genetics again. You can ask 3 questions, I guess, about genetics. Why? Why are this is genetic code? So if you have like, they're letters, right? In your DNA, they're letters, they're molecules, they're nucleotides. So this is actually RNA, that's why it has U's, otherwise it would be T's, right? So why is UUU encodes a phenylalanine? Basically, the DNA is just for the non-biologists. The DNA encodes protein. So 3 letters give you a certain amino acid that gets attached to this protein. So why is UUU phenylalanine, UCU gives you a serine? Could be the other way around, right? I don't think there's a physical reason for that. Maybe there is, but I think it's just a historical accident. Whatever primitive bacteria survived 3.8 billion years ago happened to have this. I mean, as competitor against the others, happened to have this code versus some other code, and they were stuck with it. You know, there's no physics in this, I don't think. But it's very important, right? What does it mean? So this just tells you why do we have a certain code. But what does it mean? Here's like this different genes called Hox genes that tell you that they kind of encode different parts of your body. There are different other genes do other stuff. What do they mean? That's not physics either. But physics is in here. Why? How? How does the whole thing work? How does this get translated to that and then do this? To understand that, you need to have some physics. You need to understand how these things get translated, what are the interactions, what are the forces. So you need all of those, right? So we need reductionism to understand everything, but it's not sufficient. It's not going to explain everything, right? So here's my good and bad thing. Bad reductionism is kind of the Ernest Rutherford reductionism. You want to reduce everything to elementary particles and atoms, right? Believe once reduced phenomena are explained. Well, that's obviously not true. But I think these days I have to yet meet a physicist, except for some particle physicists, who believe such a thing, right? Most of us don't believe that. Even an atom is a holistic kind of thing. It's really tough to deduce all the properties of a complex atom. On top of looking at Joe, because he's an atomic physicist, it's difficult, it's a very complex thing. Just an atom is a very complex thing. Then you have the base holism, which says that there's no utility to reduction. We just have to look at the whole thing. Hopefully about breaking this thing. That's good work. Sorry about that. Denies any utility of reduction. We just look at the whole thing kind of in a, I don't know how. I mean, how can you look at something as a whole without trying to at least analyze it in some way, right? You cannot find anything out of it. Just when you're looking at this thing as a whole, I'm like, okay, translate over there. Okay, I'm done, right? I mean, if I want to find out how this thing works, I'm going to have to open the cover, right? Yeah. I mean, so that's denies unity of science. How can that be? I mean, how can biology have nothing to do with physics, and physics have nothing to do with biology? It goes both ways, Just want to. Helmholtz actually figured out his law of energy conservation by doing biology, by the way. And it overemphasizes variation, things being different, over trying to find things that are common, right? And there are many common things. Everybody's cells basically work the same way, right? So there are good ones in the middle. So a good reduction will provide insightful analysis, reduces phenomena to the correct lower level of explanation, not a brain to quarks. That doesn't make sense. But a brain to neurons, maybe that makes sense, right? Recognize that not everything is explained in reduction. There are historical accident, random variation, chaos, all kinds of other things. Good holism would be one that searches for emergent properties arising from a reduced level, but for that you have to know about a reduced level, right? You cannot deny that there is one. Tries to explain complexity as a result of necessity and chance. I think that's an important thing. So if we do that, then we are okay. So Maya, again, this is one of his statements of kind of what I call bad holism. Reductionism is the declared philosophy of the physicalist, I don't know about that. Reduce everything to the smallest parts, so it's a typo. Determine the properties of parts and you have explained the whole system. I don't think any normal going physicist would believe that. I mean, you cannot explain a superconductor or semiconductor by reducing it to atoms and electrons. You have to see how they interact with each other. Otherwise, there's no such thing. But then he says a little bit later, and that's really, this is what it's all at. He says, rejecting philosophy of reduction is not an attack on analysis. No complex system can be understood except through careful analysis. However, the interaction of components must be considered as much as the properties of the isolated components. That's it, right? That's it. So, I have to answer my question. Can physics explain life, right? This was the whole point. So here's Ernst Mayr. To elucidate the nature of this entity called life has been one of the major objectives of biology. The problem here is that life suggests something, substance or force, and for centuries philosophers, biologists have tried to identify this life substance or life vital force to no avail. In reality, the noun life is merely a reification of the process of living. It does not exist as an independent entity. One can deal with the process of living scientifically, something one cannot do with the abstraction life. I would agree with that. So I guess we changed the thing then.